them we get 3 plus 11 by 2, and okay, this can be further simplified. X minus 1 minus, you can simplify it, 3 by 2, 3 by 4, and on multiplying them we get x square minus 3 or 1, 4x plus 3 plus 1 by 16, and on taking the product of all these three terms gives you x cube minus 9x square plus 23x and minus 50. So this is the so far result we obtained. Now if we take out 1 by 16 as a common factor, this is your common factor, inside we get 48 plus 88 times x into 88x minus 1, and then minus 12 from here. Inside this gives you x square minus 4x plus 3, and 1 by 16 is out, and remaining is plus x cube minus 9x square plus 23x and minus 15. So this is the so far output. Now you have to further simplify this bracket. So let me write on the top. So here you can see we are approaching towards the ultimate result, which is of course in the form of a polynomial, and this is the polynomial we are basically looking for. Okay, after further simplification and on splitting the brackets, we get 1 by 16 outside, and inside there will be 48 plus 88 times x plus minus 88 minus 12 times x square, 48x, 36 plus x cube minus 9x square plus 23x and minus 15. So this is the result we obtained from the last step. And you can now join all the like terms. We get 1 by 16 outside, and on simplifying all these we get x cube minus 21 times x square plus 159x and 91. So here you can see ultimately we succeed in finding the polynomial which we are basically looking for. So this is the polynomial we get. And now whenever we have a polynomial, then it is much easier to find any value of the data either within the data points or out of the data points. So as I told you, there was another requirement of this question. The next requirement is to calculate the values of y at x is equals to 2 and at x is equals to 12. So here these are the two requirements of this question, and those can be obtained very easily. I hope you can do it of yourself just by putting 2 in this polynomial and simplify. You will be getting the value of y corresponding to this 2. Similarly, the next will be you have to put x equals to 12 into this polynomial, and you will be able to find out the ultimate result. So this was the first part of our today's discussion, in which we learned how actually we can construct the polynomial by using the Newton's forward difference interpolation formula. The same result, look at it, the same result we can obtain by using the backward difference interpolation. The only difference will be the value of p, because we have to choose the end point as your starting point, and the value of p will be changed. But if you do the same calculation and your work is errorless, so definitely you will be reaching to this result. In both the cases you will be obtaining the same kind of polynomial. So after completing this work, now we jump over towards the next aspect